Welcome to Geometry 3-6, Lines in the Coordinate Plane. Go ahead and pause the video and attempt these 4 warm-up problems. Okay, the objectives today are to graph lines and write their equations in slope-intercept form and point-slope form. Also, we will classify lines as parallel, intersecting, or coinciding. So, let's talk about the equation of a line. The equation of a line has many different forms. So we're recalling back to last year, algebra. And one form, probably a less familiar form to you, is the point-slope form. So if you recall, we said got point, got slope, you can use point-slope form. See if you can jot down point-slope form. We'll take a look at that in just a moment. The other most favorite and familiar form is what? Yep, slope-intercept form. Okay, there are other forms. Can you think of the form where we just have ax plus by equals c? What do we call that form? Yep, standard form. So, remember that when we're dealing with vertical and horizontal lines, they're kind of special cases, huh? So vertical lines, slope, all rise, no run, all rise, no run. So the slope is undefined. So it may not be written in these forms. If we don't have a slope that is defined that we can use, we have nothing to plug into the slope part of these two forms. Okay, I hope you thought about what point-slope form looks like. Got point, got slope, and I will provide you with this little graphic to tape into your concept book. And let's see if we can say it together. Point-slope form, y minus y1 equals m times x minus x1. One known point, x1, y1, is inserted along with the known slope. We have an unnamed x, y pair, and when we simplify this type of point-slope form, we can distribute, right, and isolate y and take it down to slope-intercept form if we want to. So let's recall slope-intercept form. Y equals mx plus b. Good. So the slope, m, the y-intercept of b. If you know those two things, you simply input them. Okay, finally, remember that the vertical line has, we identify it just simply as x equals a. You know, what value is the x on a vertical line, and in this case we have 5. And a horizontal line would be the y value, right? Y equals b. Looks like the y-intercept, doesn't it? So y equals 2, we would rise 2, rise 2, rise 2, rise 2 everywhere and have a horizontal line. Write the equation of each line in the given form. The line with slope 6 through 3, -4 in point-slope form. So the question is, do we have point? Yes. Do we have slope? Yes. So we can use point-slope form. Okay. So the generic point-slope form, let's just put the model down. Again, see if you can do it from memory. Y minus y1 equals m times x minus x1. Good. Okay, so now we simply substitute the known point carefully and the known slope. Okay, so don't forget x comes before y, so -4 will be our y, 3 our x, 6 is our slope. Good. And now we have subtracting a negative, which sometimes we will simplify, right? So just substitution, that's all that's required. Okay, write the equation of this line in slope-intercept form. We have a point -1, 0 and a point 1, 2. We need to write this in slope-intercept form. So let's recall slope-intercept form. Whoops. What are we? Slope-intercept form. We're going to be asked down here. Okay. So slope-intercept form is y equals, yep, mx plus b. So what do we need? We need slope, don't we? So let's recall how we find slope. M equals the change in the y's, rise, over the change in the run, right? Good. So we have the change 2 minus 0 over 1 minus negative 1. 2 over 2 equals 1. So we now have a slope of 1. If we're going to write this equation, we need slope, and do we have the y-intercept? Now, if we had the y-intercept, no walking, all flying, right? The x value would be 0. So we don't have it. So what might we do to find the y-intercept? We know slope is 1. Do we have a point that we could plug into xy? We actually have 2 points we could plug in, right? So we would plug one in, substitute a known point and slope, and solve for b. So b equals 1. We now can substitute 1 and the slope of 1 into the equation. And you have it. Write the equation of each line, this line now, with the x-intercept of 3 and the y-intercept of -5 in point-slope form. So if we have an x-intercept of 3, what is the value, or what is the ordered pair associated with an x-intercept? Well, an x-intercept crossing the x-axis. Crossing it at 3, we have no flying, right? So the value would be 3, 0, right? A y-intercept, there is no walking, all flying, would be 0, -5. So we're going to use that information and plug into point-slope form that information. Since we have a point, 3, 0, and 0, -5, we can substitute that into our slope equation, right? So we are going to find that the slope is -5 minus 0 over 0 minus 3, or slope of 5/3. Good. And so we now have slope, and we have 2 points to choose from for our point-slope form. So we will substitute either of those points in. In this case, the x-intercept has been plugged in. X is 3, y is 0, and our slope is 5/3. This can be simplified to point-slope form. Actually, they asked for point-slope form, and it looks like we have it here with the -0, but because we're subtracting 0, we can simplify it to just y equals 5/3 times x minus 3. Okay, let's recall how to graph a line. When we have a line in slope-intercept form like this, and we're asked to graph it, do we have a point? The point is, you got it, the y-intercept. So we can place that on the y-axis, and then we have slope. Slope is rise over run. So we will take from our y-intercept of 1, we will rise 1 and run 2. We now have a second point at 2, 2. And 2 points are all we need to graph a line. So draw your line through and beyond. Make sure that you have arrow tips on the ends of your line. This has been cut off a little bit so you don't see the arrow tips. We can also graph a line in point-slope form. We don't even have to change this to slope-intercept. Do we know slope? Yep, -2. So -2 over 1 would be our slope. M equals -2 over 1. We also know a point, don't we? See if you can write that point down. X minus x1, so that must be a -4. And y minus y1, and that's +3. Good. So now we're back to where we were in the previous example. We plot our point. Well, actually, in that case, we had a y-intercept. In this case, we don't. We plot the point, and we use slope of -2 over 1. And this is what it looks like. Plot point -4, 3. There it is. And now we can use a slope down to run 1 to find a second point, and draw your line. Recall graphing a special case line. A line that is y equals -3. Well, in that case, we can begin with just a basic coordinate plane. Let me draw one here. I'm not going to take the time to label this. We know x and y, you would have to plug in your values, right? Y, what I want you to think about is if you start at the point of origin, you would, to find y is -3, which direction would you travel? Down 3. Good. So you would go down 3. From any place, I would go down 3, resulting in what type of a line? You got it. A horizontal line at y is -3. So here's what it looks like. Special case. When asked to graph parallel lines, what do they have in common? You got it? They have same slope, right? Different y-intercepts. Okay, I'll give you a copy of this little thing and you can tape it in your notes. How about intersecting lines? Do they have the same slope? Never. No. They have different slopes. Could they have the same y-intercept? I guess they could. They definitely have different slopes. And coinciding lines end up having same slope and same y-intercept. When reduced down to slope-intercept form in its simplest form, they are the same line. They usually are given to us looking different, but they end up being the same line. Are these lines parallel, intersecting, or coinciding? Well, all you have to do is identify the slope. We have a slope of 3 and a slope of -3. Same slope? No. Intersecting? Yes. Different slopes, intersecting lines. Are these parallel, intersecting, or coinciding? Well, this has a slope of -1/3. What is this slope? You're going to have to transform this equation to isolating y so that it's in the same form as the first equation, right? So let's divide both sides by 6. And when you do, you end up with a -1/3 slope in the second equation. So the next question is, do they have the same y-intercepts? 5 and 2? No. So these lines must be parallel. Okay, try this lesson quiz. Pause the video, give it a shot, and then I will come on back and you can check your answers. And here are the correct answers for part 1. Pause the video and compare those with your answers. Now finish the quiz by determining whether these lines are parallel, intersecting, or coinciding. Pause the video and answer the questions, and then come on back and check out the answers. Yep, intersecting and parallel lines. Very good. This is your assignment, and have a great time. Enjoy.